Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at proof by contradiction. So like proof by contrapositive, this is an indirect method of proof. We're not really proving it directly. See, what we do in proof by contradiction is we assume the thing we want to prove is false, and then we go through a series of steps to arrive at a contradiction. We basically show that if this statement was not true, we would get something absurd. So let's look at doing that. Here, there are no positive integer solutions to x squared minus y squared equals 1. You know, a lot of people say you can't prove a negative. Well, in maths you can. And proof by contradiction is a very good tool to prove a negative, to prove that something can't happen or won't happen. What we're going to do is assume that it does happen and then show that that is crazy. So we are going to start by assuming that there are positive integer solutions to x squared minus y squared equals 1. So positive integer solutions means that both x and y are positive integers. So we're going to factor x squared minus y squared. We know that from the difference of two squares, we get x minus y times x plus y is equal to 1. Now, if x and y are both positive integers, this is an integer and this is an integer. So we have two integers multiplying to be 1. So the only possibility is either both of these integers are equal to -1 or both of them are equal to +1. They're the only two possibilities. You can't have any other pair of integers multiplying to give 1. Now, firstly, this one definitely can't be true because x and y, remember, have to be positive integers. You can't add together two positive integers and get a negative number. That's absurd. So this case is not possible. What about this case? Well, if x minus y equals 1 and x plus y equals 1, the only solution to that is x equals 1, y equals 0. You can get that from adding together the two equations and solving them like we used to. So we said x and y need to be positive integers. 0 is not a positive integer. So this case gives us something absurd as well. So we have just shown that there can't be any positive integer solutions to this, because if there were positive integer solutions to this, we would arrive at a contradiction. The contradiction being that the sum of two positive integers is -1, or that one of them has to be 0. So we have shown that if you start with this premise, you get a contradiction, so our original statement here was false. All right, let's now look at proof by contradiction by proving irrationality. So a proof by contradiction is very helpful in proving that numbers are irrational. So we're going to prove that root 2 is irrational. So when we're using proof by contradiction, what we're going to start is by assuming our proposition is false. So we're going to assume that root 2 is rational. So just so you know, there are no numbers or no real numbers that are neither rational nor irrational. If a number's not irrational, it must be rational. So we're going to start by assuming this and showing that we get something absurd. So if root 2 is rational, what that means is we can write it as a fraction in the integers. That's what it means. All rational numbers can be written as fractions where the numerator and denominator are both integers, and we can simplify that fraction too. So we're going to also stipulate that the highest common factor of a and b has to be 1. If a number's rational, you can write it as a fraction, and if you have a fraction with integers, you can always simplify it so numerator and denominator have no common factor other than 1. So let's play around with this and see what happens. Well, just to make things easier, I might get rid of the square root. I'm going to square each side. So if you square root 2, you obviously get 2, and then I'll get a squared over b squared. So if I multiply now each side by b squared, I get 2b squared equals a squared. So what can I deduce from this? Well, if a squared is equal to 2b squared, that means a squared is even because it is 2 times an integer. But if a squared is even, then so too a is even. Okay, that's no problem so far. But what about 2b squared? Well, this has to be a perfect square because it's an integer squared. The only way that that's possible is if b squared is even. Think about it in terms of prime factors. You can't have 2 times a square number equaling a square number, because 2 is not a perfect square. In other words, if we look at the prime factorization of b squared, it would have to also have a prime factor of 2, so you'd have 2 times 2. Another way to look at this is if a squared is even, that means a squared is divisible by 4. That's what that means here. A squared is divisible by 4. But if a squared is divisible by 4, that means this has to be divisible by 4. It's got a factor of 2. It needs another factor of 2. Either way you look at it, b squared has to be even, and then b must also be even. But this is a contradiction because we said the highest common factor of a and b is 1. If they are both even, then their highest common factor is not 1. It means they must have a common factor of 2. They could have other common factors as well. So we've arrived at a contradiction. We've basically shown that if root 2 can be written as a fraction, it can't be simplified. What kind of fraction can't be simplified? Well, that's one where they're not integers at the top and the bottom. So we have shown by contradiction, root 2 cannot be written as a fraction with integer numerator and denominator. Therefore, root 2 is irrational. When we assume root 2 is rational, we get a contradiction. So our original statement was false, and we conclude that root 2 is irrational. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.